This is number 24 on page 289, and I'll read it here. Talks about a battleship when a load of 1 times 10 to the 6 newtons, that's 1 million newtons, is placed on a battleship. The ship sinks only 2.5 centimeters in water. Estimate the cross-sectional area of the ship at water level. And so to do this problem, there's one really important thing you got to remember, and that is the fact that when something floats, the upward buoyant force, FB, is always going to be equal to the weight, FG, which is equal to mass times acceleration due to gravity. All right? Well, if that's true, I don't have mass, I don't have G, I have G, but I don't have mass, and that's not going to help me anyway, because I want to find area. Well, the buoyant force is equal to the density of the fluid times the volume of the fluid displaced times G. And here's what you got to remember is that volume is equal to area times height. For example, if you just had a raft and the raft was in water, then and see, it's not all the way underwater, right? It's underwater just a little ways. And if we look at that, the area is here, right? And then how far it sinks into the water is h, and area times height would be the volume under the water. And so that's what we want to replace right here. Is we want to replace volume with area, which is what we're trying to find, times height times G times density equals FB. All right? So let's put our numbers in. This is 1.0 times 10 to the 6 newtons equals 1024 kilograms per meters cubed times A, what I'm looking for, times 0.025 meters, that's 2.5 centimeters, times 10 meters per second squared. And so if I multiply 1024 times 0.025 times 10, I get 256. So I get 256. That's going to be kilograms per meters second squared, maybe, because that meter divides out with one of those, that meter divides out with another one, and it leaves just 1 meter down there, equals 1.0 times 10 to the 6th 10 to the 6 newtons, and I forgot my variable here I'm looking for is A. So I'm going to divide both sides by 256. So 1 second e to the 6th divided by 256 is basically A equals 3,900 if you use 10. That's meters squared. Or if you use 9.81, then you'll get about, when you round up, you'll get about 4,000 meters squared, which that's the answer the book has. This is the answer we got using 10. And that's how you do number 24.